In this video, we're going to take a look at how to get out a quadratic equation when the only information we have is the roots. So what you must remember is what the roots mean. So the roots are the points where the graph cuts the x-axis. So that's really important. Roots means where we cut the x-axis. So cut the x-axis. So what can we do with that information? Well, we're basically trying to reverse engineer. If we know the roots, how did we get to the roots from the equation and work backwards? So you will remember that when we had the generic quadratic equation, something like this, something x squared plus something x plus something, and it was equal to 0, what we would do first is we would break it into factors. So you might use the array model for this part, and you would try to have an x at the start of each bracket. Then you would break it down because you know that two brackets multiplied together give you 0. What does that mean about one or both of the brackets? Well, it tells us that the brackets are 0. So bracket 1 was equal to 0, or bracket 2 was equal to 0. And then what we were able to do is solve a linear equation. So we then reverse this and we would get x equals something, and we would get two of them because every quadratic has two roots. We're at this stage and we want to work our way all the way back to this step here. So that's all we're trying to do, is reverse engineer it. So if I'm at this stage where it's x equals, so I'm down here at this point, and I want to get to the next part. How do I do that? Well, I want to get it back to being x is equal to 0. So if x is equal to 3, I'm going to take away 3 from both sides. So x minus 3 is equal to 0. And that puts me back at the yellow step here. I do the same on the other side. If it's x is equal to minus 1, what I'm going to do is add 1 to both sides. The next thing I'm going to do then is I'm going to change these roots back into factors. So how do I change them back into factors? Well, I multiply them. So I'm going to have x minus 3 multiplied by x plus 1. I know that those two multiplied together will give me 0 because that's what roots are. Okay, so I'm back at the green step there. So I'm just reverse engineering all of the steps. So I know that because they're roots, when I multiply them together, that they'll give me the quadratic, and I know that the quadratic at the roots will be equal to 0. Now we need to multiply those out, so I'm going to multiply them out, and this is going back to first year work. X by x is x squared, x by 1 is 1x, or x, minus 3 by x minus 3x, minus 3 by 1 is minus 3, and it's equal to 0. That's putting me closer to that final step that I want up here, which is going to be the quadratic. We're really close to it now. What have I got to do but just tidy it up? So I'm going to now have x squared minus 3x and plus 3x together gives me minus 2x minus 3, and it's equal to 0. That's what we have. That is the quadratic equation. I can then write it as a function by calling it f of x, and it's equal to x squared minus 2x minus 3. And there we have it. And we know it's equal to 0 when I'm looking for the roots, or when I'm dealing with the roots. If I was asked to sketch that graph then, well, I know 3 pieces of information about it, so I can give a pretty good sketch. You will hopefully remember as well that you can use the table, that you can have an input and output table and work it out that way. But if I know the roots are 3, so 1, 2, 3, I can put a point there. The other root is going to be minus 1, which is going to be 1 this way, so there's minus 1 over here. I know that I cross the x-axis at minus 3, and how do I know that? You must know that the constant, the number on its own, that always gives away the plus c, which is where it cuts the y-axis or crosses the y-axis. So the plus c, the number on its own, is where it crosses the y-axis. So it's minus 3, so minus 1, minus 2, minus 3 is down here. And I've got 3 points there that I can start to build up a rough sketch of what it looks like. Now we will be coming on to the turning point fairly soon, but that's what they'd be looking for from us, a quick rough sketch If I had one more point, I could make it even more accurate. That one more point that I'm talking about is the turning point, which we will be coming up onto soon. We don't know that just yet. But what we do know is that we've got the 3 points, the cut of the y-axis called the intercept, the 2 roots cut in the y-axis, and I know the shape of it is going to be a U shape because all positive quadratics make a U shape. We should know that as well. Now, obviously, they're not all going to be that easy because how do we know that it wasn't an N shape? How do we know it wasn't a minus X? Because we possibly had a scenario here where this maybe was a -1, or maybe there was a coefficient, maybe there was a number in front of the x. How do we know that? Well, with the information we're given in this question, we don't actually know. But in this question, if they asked me to get the equation out from this picture, I do have enough information to figure out, is it going to be multiplied by -1 in the end? Is it going to be multiplied by another number, another coefficient, another factor? So let's work through it. The first thing that we know is that we know the roots, and the roots are going to be x is equal to -1 and x is equal to 2, because remember, the roots mean where we cut the x-axis. That's what the roots are, and that's where this graph cuts the x-axis, in these 2 locations. The next thing that I know is that I'm trying to reverse engineer all of the steps that I normally do to find the roots. So remember this box up here? This up here is what we normally do when I want to find the roots. I'd start with the quadratic. I know that the quadratic is equal to 0 at the roots. I factorize it, it's still equal to 0. If I have 2 things multiplied together to give me 0, then one or both of those things themselves are 0. And then I can work out x because we're down to linear equations. I'm now at this step, the pink step, and I'm going to work back until I get the equation out. So let's do that. I'm at the roots and I want to get to factors. So how do I work backwards to get to factors? Well, remember, before it was equal to -1, it would have been x plus 1 is equal to 0. And the same on this side, x minus 2 is equal to 0. The next thing, they're not quite factors yet. I'm getting closer. I want to, if they're factors, they're going to multiply together. So I'm going to multiply these 2 things together. So I'm going to have x plus 1 by x minus 2. And those 2 things together equal to 0. Because I know that the quadratic itself, the shape of the quadratic, it's on 0 on the y-axis. The f of x is on 0, flat on the y-axis, or flat on the x-axis. And that's where the roots happen. So I'm letting the 2 multiply together because they are factors. Factors means multiplied together to give me back the quadratic, and they equal to 0. So now I'm going to multiply that out. I get x squared plus x minus 2x minus 2 is equal to 0. Tidying that up, then I get x squared minus x minus 2 is equal to 0. Now, in this case, I can check out more information about it to see, do I actually have the right quadratic? So there's some things that I can look for. Is the shape of the graph correct? So this is a positive quadratic. Positive quadratics are happy. They're positive. They're a smiley face. Okay, that is correct. It is a smiley face. The next thing I can check is to check that the plus c matches, and I'm going to check. Remember what the plus c means, or what the plus c tells us. So the plus c in this case is -2 for the equation that I've got. But actually, in this case, the plus c on the graph, if we look at that, where is it cutting the y-axis? It's at -4. So that's a bit of a tell. It tells me that the graph cuts the y-axis at -4, which means that the plus c, or the number on its own with no x attached to it, that should be -4. So it's telling me that there's actually a scaling factor, something that I have to multiply everything through to get the correct equation for this graph. So I'm going to actually have to go and multiply my whole graph by 2. Because the plus c from the equation did not match the plus c from the graph. It was twice as big. So that's something we need to keep an eye out for. So I'm going to multiply this through then, and I get 2x squared minus 2x minus 4 is equal to 0. Now, looking at it, the plus c's do match up, and you might be thinking, well, does that not change the roots? And here's the thing. If we actually work through this right now and we factorize it, and I work through the factors of this, and I say it's 2x and x, and I'm going to have 2 and 2. I'm going to say minus and plus. If you're not sure what I've done there, please pause it. What I'm doing is I'm working through the quadratic and factorizing it. Okay, so please pause and check it if you're not sure. But I've just factorized it. I'm just checking that my roots are still the same. So let's check it out here. I'm going to have 2x plus 2 is equal to 0. And I'm going to have x minus 2 is equal to 0. Then in this case, I get x is equal to 2. And in this case, I get 2x is equal to minus 2. And look what happens. I still have to divide this side by 2, and I get x is equal to minus 1. Now, what do we notice? Let's go back up. These are the two things here. They're called roots, remember? The roots at the start were minus 2 and minus 1 and 2, and I get back out minus 1 and 2. So the scaling factor actually does not change where the roots are. So that's really important fact that we will discuss more when we do the transformations. But for now, just know that if you're given more information, when you're asked to take roots and turn it into a function, look at the clues in the picture to make sure that they match up. So check your understanding. Does my plus c match the plus c on the graph? Does the shape of my graph, the U shape or the N shape, does that match what I'm told it should be according to the picture? Alright, so everything there you have done before. If you've worked on factorizing and you've built up that skill and you've really pushed yourself and gotten really good at factorizing quadratics, we're now working backwards. So all of the steps that we did before, where we took it, factorized it, let it equal to 0, took our two factors, let them equal to 0, and then solved the linear part, we're now just starting with the end and working our way back to the top. That's all that it is. It's a little bit trickier when you're given a graph, but it's there to help. It's there to give you clues to check out, do we actually have the right function? So that's all. It's there to help you.